Welcome to the deep dive. Today, we're tackling a topic that is changing faster than our ability to really regulate it or even define it,
Mm.
the explosive evolution of artificial intelligence.
Yeah, and we have a mountain of sources here. We've got everything from the deep technical breakthroughs to the philosophical impact on things like human creativity.
And our mission really is to give you the most crucial insights from all this material. We're going to unpack, I think, three core threads.
Exactly. First, we'll look under the hood at the technology itself, how these models actually learn to reason. That's a huge leap.
Then we have to get into the societal disruption, the singularity, the economic shifts, all the big, scary stuff.
And finally, we'll look at this real-world friction between the speed of innovation and, frankly, the dead weight of regulation.
That's a huge stack.
Yeah.
So let's start with the engine itself. We're way past the point where these language models were just, predicting the next word.
Oh, miles past that. Our sources are all pointing to the same thing. The critical leap is the model's emergent ability to actually solve problems, to reason.
So what fundamentally changed? How did that happen?
What's so fascinating is that it's not some external thing we bolted on. The reasoning is it's encoded into how the model uses language. This is the whole chain of thought breakthrough.
Okay, we hear chain of thought or cut thrown around all the time. For you listening, what does that actually mean? It sounds like it's just writing out its steps.
It sounds like that, but it's much deeper. Think of it this way. If you ask a model a really hard math puzzle and you ask for the answer in one go, it'll probably fail.
Right.
But if you prompt it with something like solve it step by step, it generates a sequence of tokens. And that sequence is the thinking process, written out.
Ah, okay, so it's using its own output as a kind of temporary memory, like a scratch pad.
That's the perfect analogy. It's not just verbalizing a pre-calculated answer. The act of writing the steps, of generating that token sequence, is what allows it to do the complex computation.
The process is the solution.
Precisely. It lets it connect ideas logically in a way that's impossible in a single jump. But that raw ability then gets refined by something else. Reinforcement learning.
Right, RL. The analogy is always training a dog, but that feels a little too simple for something like GPT-4.
It is. It is. The principle is the same, rewarding good behaviors, but it's so much more sophisticated. We're using what's called a reward model that scores the AI's output based on human preference.
And that's RLHF, reinforcement learning with human feedback.
You got it.
Yeah.
So human reviewers score the model's answers for helpfulness, for accuracy, whatever. Then a second AI learns those preferences.
And that second AI becomes the cookie dispenser for the main model, training it to produce outputs that humans will find helpful and coherent.
Exactly. And that technique was absolutely key for what we saw in GPT-4. It's what took us from, say, GPT-1 being a cool tech demo
Good at puzzles, but not much else.
to the sort of meaningfully useful, world-changing systems we have today.
And now the focus is on making them think even longer, right? Connecting multiple tools, interacting with databases, that sort of thing.
Yeah, and we're already seeing proof that these things are competing with the best human minds.
You're talking about the ICPC competition.
I am. The sources highlight this. You have AI systems solving 12 incredibly complex algorithmic problems in the world finals. Their performance was equivalent to a human team winning first place.
That's not potential anymore. That's here.
That is current operational reality.
Okay, so connecting that technical reality to the bigger picture, the pace of all this is what's so hard to grasp. The sources call it double exponential and choppy.
That's where people get tripped up. Double exponential just means you have two growth curves multiplying each other. First, you have Moore's law, the hardware getting faster.
And the second.
The second is the algorithmic breakthroughs like chain of thought. The software is getting smarter at using the faster hardware.
So it's a force multiplier.
A huge one. And it's choppy because it doesn't happen smoothly. It happens in these massive sudden jumps. The leap from GPT 3.5 to 4 was something like a 10 times performance increase.
Wow.
And if that trend continues, some projections suggest we could be looking at an AI with an equivalent IQ of 1,500, and soon.
That's a number that doesn't even make sense. What's the difference between a genius at, say, 180 and 1,500?
The analogy one source uses is the difference between a golden retriever and Albert Einstein. It's a gap that fundamentally redefines problem solving, which brings us directly to the singularity.
The moment an AGI becomes smarter than humans in everything.
Right. And the predictions are all over the map. You have Ray Kurzweil saying 2029, others saying 2025, 2027.
So next year, possibly?
But one thinker makes a great point. The exact date doesn't matter as much as preparing now. Because, philosophically, an alien intelligence is already here.
I like that framing. We're already dealing with a non-human mind, and that brings up the disruptions. Mo Gaudat lays out 4 massive existential dilemmas. First one is jobs and purpose.
And this is the one most people feel in their gut. What happens when the smartest, most competent person in your company is a machine? It's not about automating menial tasks anymore.
It's about automating the CEO, the strategist.
Exactly. Which leads straight into his second point, the concentration of wealth.
This feels like the really dangerous part.
It is, because the barrier to entry is billions of dollars. Only a handful of companies, OpenAI, Google, Meta, can build these things. So the public inputs the data, the prompts, the digital seeds, so to speak.
But the owners of the automation become the new kings.
And if only a tiny fraction of people own the intelligence that creates all the abundance, inequality could become catastrophic.
The third dilemma hits at reality itself, the end of truth.
We've all seen deepfakes, but the sources point to something more subtle. It's the AI generating highly convincing, persuasive falsehoods at an unbelievable scale.
Whether that's creating impossible beauty standards or just making up facts that influence an election.
Right. If truth becomes infinitely customizable, what common ground is left?
Genuinely terrifying. And the fourth, of course, is the arms race.
Whoever gets to superintelligence first has an irreversible advantage. They could, in theory, stop anyone else from ever catching up.
So the big question hanging over all of this is, what do we do? The sources seem to agree the threat isn't intelligence itself. A super smart AI could solve climate change, cure disease.
It could create incredible abundance. The danger is human greed. The challenge is ethical. How do we prioritize humanity over a purely capitalist system that just wants to extract profit from this thing?
Which brings us to the immediate challenge, governance. How do our current systems even begin to cope?
They don't. That's the problem. Our sources highlight this massive amount of friction that's just sabotaging progress.
One expert called it a regulatory tax on innovation. I loved the analogy of Gulliver tied down by a million tiny strings. Each individual regulation seems reasonable.
But the accumulation of them all just makes everything nearly impossible. It grinds innovation to a halt.
And you see the cost of this most clearly in big infrastructure projects. The example of the California high-speed rail is just, it's absurd.
It really is. $7 billion spent for a 600-foot segment of track. And even after all that, there's no actual rail laid down.
Just 600 feet of concrete and a mountain of paperwork. And the speed comparison is what really drives it home.
It's staggering. To build a gigafactory, Tesla needed 2 years just for regulatory approvals in California. In Texas, the whole thing was built in 14 months.
And China?
11 months. The regulation isn't just a hurdle, it's the main bottleneck that costs economies billions.
The SpaceX example was even more wild. They were fined $140,000. For what, again?
For dumping portable drinking water. It was used to cool the launch pad. It was perfectly safe drinking water, zero environmental harm, but they didn't have the right piece of paper.
That's the friction. If your system can't handle a permit for drinking water, how is it supposed to govern an AI that can redesign itself every hour?
It can't. And this inefficiency isn't just slowing down tech. The sources also point to the fact that the U.S. is, quote, going bankrupt extremely quickly.
The numbers are pretty stark.
They are. Interest payments on the national debt are now over $1 trillion a year. That's more than the entire defense budget. The argument is we need a serious reduction in government size just to stay solvent.
And we have historical proof of this, right? The East versus West Germany example.
A perfect case study. East Germany was 100% government-run. West Germany, about 50%. The difference in standard of living was 5 to 10 times higher in the West. It just shows that the operating system is structurally inefficient and can't handle the speed of AI.
Okay, so that's the perfect pivot. Let's shift from the anxiety around this general out-of-control AI to looking at it as a specific creative tool.
Yes, and this is where things get really interesting and frankly more hopeful. A great example is Google's Notebook LM. It's an attempt to design AI as a responsible, grounded tool, not some all-knowing oracle.
Grounded. That's the key term. So it's grounded in your sources, right? Your notes, your books, your research.
Exactly. The model is deliberately restricted. It can only answer questions based on the facts inside the documents you provide.
And it gives citations for every single statement.
Which is huge. It dramatically reduces the risk of the AI just confidently making stuff up, of hallucinating. It's your own personal intelligence that works only on material you trust.
We're seeing some amazing features come out of this, like the audio overview that's gone viral. It basically turns your dense documents into a little podcast.
A personalized conversation between two AI hosts, yeah.
Mhm.
It's an amazing way to absorb complex information quickly.
But beyond the tools themselves, this shift points to something one source called the revenge of the humanities.
I love that phrase. The point is that the hottest new programming language is English. To get high-quality output from an AI, you need strong writing skills.
You need convincing, clear, declarative sentences.
That's the quote. It's fascinating, isn't it? We thought everyone would need to become an engineer, but it turns out that clear prose is one of the most valuable skills.
It really elevates writers and communicators. And this idea of AI as a tool extends deep into the creative process itself, with nurturing what's called the slow hunch.
Right. Real creativity often comes from these ideas that incubate for years. A note you scribbled down a decade ago, a half-formed thought.
And they're all disconnected, in different files, different notebooks.
But a tool like Notebook LM can find the semantic links between all those old forgotten notes. It lets you, in effect, brainstorm with your past selves.
The proof of this is pretty profound. There was an example of a model that analyzed a 110,000-word book.
A very long book, yeah. And it was able to accurately identify and explain where the author deliberately withheld information to build narrative suspense.
Wait, so it understood the author's intent and understood a complex literary device like building tension without being conscious?
It did. It understood the structure of the narrative arc, which proves that when this technology is grounded and focused, it can be an unbelievably powerful creative partner.
So let's tie this all together for you, the listener. We have AI accelerating past all human expectations, which creates this profound ethical and regulatory challenge.
And our governance systems are just. They're completely out of date and unprepared.
So the core tension really seems to be about how we choose to deploy this technology. Are we going to keep building systems designed to be anthropomorphic, to maximize addiction and engagement?
You mean like the AI from the movie Her? Systems that are designed to trick us. They display text one letter at a time to fake thinking or use these flattering, emotive voices?
All for engagement, all for deception, really.
Or do we shift decisively towards specialized tools? Tools designed for clarity, for efficiency. Tools that solve specific human problems without pretending to be human.
Like that project to preserve the Murray language or these focused mixture of experts models.
Exactly. So the provocative thought to leave you with is this. Given how powerful these systems are, how quickly will we, as a society, move past the need for drop shadows and cue voices?
When will we, the users, start to demand that our AI partners look and act like the powerful, focused, responsible tools they truly are, prioritizing utility and truth over simulated companionship?